Reintroduction. So first we're going to start with Jeremy Lundholm. And Jeremy, I have you listed as St. Mary's University. You correct me if I'm wrong. I see that there's a number of partners listed on the first slide of your presentation, and that's wonderful. We'll pass it over to you, Jeremy, and welcome.
Great, thank you. Hi, everyone. I'm Jeremy, and talking to you from here in Ojibuktuk, Halifax in Mi'kma'ki, and I'm going to be talking about the role of tidal marshes in climate change adaptation and mitigation today, hopefully briefly. And yeah, I'm all of the above. The three groups down below are all intertwined in these projects. So first, to focus on Southwestern Nova Scotia, tidal marshes in Kishpuktuk. We know already that these have substantial biodiversity value. They're valuable habitats. I'm quoting extensively here from this great report from Leslie and Pat from NPRI in 2013. But today, I'm mostly going to be talking about coastal protection and carbon sequestration. But it's important to note, like especially in this region, tidal marshes are really important. This region hosts 43% of the important tidal marshes in Nova Scotia, but the land area is only 29%. So we're kind of, hitting above our weight here. And, I'm going to focus on how these systems can help mitigate and adapt to climate change. So the tidal wetlands, as some of you probably know, they provide a whole bunch of different services that are useful, for other organisms and the rest of the environment and for humans. They're migration corridors. They represent important habitat for young fish in terms of nurseries. A whole bunch of organisms live there. We know that. They're also really productive systems. And so for the carbon piece, they do produce a lot of, they have high primary productivity. They're also good at storing carbon, and I'll explain how that works. Specifically on our coast, from the perspective of sea level rise, tidal marshes are useful potential tools in adapting to sea level rise because naturally they accumulate sediment and they can retain that sediment and actually basically convert open water habitats to terrestrial habitats, land habitats. And finally, they protect the coastline against erosion through the dissipation of wave energy and flow energy. These are really dynamic systems. So all of our coastline is quite dynamic. And it's especially important for tidal marshes. So this dynamism is something they capitalize on. There's some old photos of this region in the Upper Bay of Fundy near Windsor, where a causeway was built. And now, 3 decades later, there's this massive salt marsh there. So things can happen very quickly. And tidal marshes drive these changes through natural processes of erosion and its converse sedimentation. So, sediment moving around and accumulating in different places, essentially. So it's a dynamic system, but tidal marshes themselves are really resilient. And we capitalize on this resilience to use them in the face of sea level rise and other issues associated with climate change. So first of all, marshes can migrate horizontally as the sea level rises. Essentially, they move inland, but they also accrete vertically. And so they trap sediment, and through plant production and other processes, the marsh surface raises up. So these are really important processes, and I'll get to some of the key drivers behind these processes and how they all work just briefly before we get into some local projects. So salt marshes, tidal marshes act as ecological engineers. This is partly the role of the plant, but it's how the plants interact with all the rest of the system. It's really complicated. My colleague, Dr. Danica Van Prusi at St. Mary's, uses these diagrams to scare students. And this is a very simplified version of this, but it's great because they self-organize. This is a natural process, and they naturally recover from disturbance, and they can track sea level rise over time if the conditions are right. And we'll get into what some of those are. So one of the key environmental drivers is tidal range. So that's really sort of the difference between the lowest tides and the highest tides. What is that vertical span, right? And in this region, it's very important. It influences pretty much everything in a tidal marsh system: the flow of water, the hydro period, which is really, in a simplified version, just the amount of time that the system is flooded. It also moderates sediment accretion and all these other things, including vegetation zonation. So we know that throughout Nova Scotia, there are clearly delineated vegetation zones, and these are found at different elevations. So it's very obvious. It's one of the nicest ecosystems to work with in terms of habitat classification because you get these strong zonation, at some sites anyway. So tidal range varies greatly throughout southwestern Nova Scotia. Of course, we've got the upper Bay of Fundy, which have some of the hugest tides in the world, so a range of up to 15 meters. As we come around the corner, around Kisbukwick, we've got, going down to about 6 meter range tides. And then on the Atlantic coast, tides are lower in range from about, 1.5 to 3 meters. And this is really important. Obviously, we need to know the range of the tide. So that's key data that we use in going forward, planning, salt marsh restoration projects and whatnot. But we think that the general concept is that areas with higher tidal range are actually less susceptible to sea level rise in some ways. They can be more resilient, in part because they already have such a huge range. But I'll talk about some of the other factors that mitigate this. And one of the important ones is sediment supply. So sediment washing around in the Bay of Fundy, it's basically the mud that you see that gets deposited, and it's what makes the water that color, especially in the upper bay. So this heat map just shows where the highest sediment flux is. And so the variable here is just the movement, the transfer of sediment. And you can see as you come around, there's still quite a bit of sediment in this part of the bay, part of Kisbukwick here, but also coming around here, sediment supply gets lower. And that has implications for how tidal marshes are going to respond to sea level rise and other climate change implications. And one of the things that we understand is that as sediment availability goes up, so if you're in a region that has a lot of sediment supply, you can probably still have a tidal marsh that's sustainable at a higher sea level rise, right? Because essentially that sediment is one of the raw materials that allows the marsh to build up and basically get ahead of sea level rise. So that's really important. What happens if the accretion, the vertical growth of the marsh can't keep pace with sea level rise, it basically moves into this other state, which would be an open water habitat, right? So carbon sequestration is one of the things that salt marshes are really good at, and this is also carbon storage. First of all, that sediment that's washing around, that gets trapped and it gets stored over long periods of time in a healthy salt marsh. We also call this blue carbon. And so there's been a number of studies that show that marine habitats, especially coastal habitat like salt marsh and eelgrass beds and mangroves that we don't have up here, are often better at storing carbon than terrestrial ecosystems like forests, for example, partially because that the carbon that's trapped in sediments can be stored for long periods of time because decomposition rates are so low. The salt water and the fact that it's just inundated, for at least part of the tidal cycle, reduces decomposition rates. And so there's a net storage of carbon. That's what we understand anyway going into this. Plants play a role here as well. Plants are photosynthesizing, they're fixing carbon, and they're shoving that carbon into their roots. These are long-lived perennial plants. They regrow every year if they're healthy, and that carbon goes into the root system as well. And that helps the marsh build up over time. And it's also adds to the net storage of carbon in these systems. The other thing that plants do, just by physically being there on the marsh, is when the marsh is flooded, they reduce flow velocities of water, which, among other things, basically allows more sediment to be trapped by the marsh system. So the slower the movement, the more that more of the sediment that falls out and gets deposited on the surface. And so that's really useful. But the plants also, when they're flooded, they also reduce wave height and wave energy, because basically they provide friction so that water moving through can't move through as freely. So these are some benefits that help with coastal protection that are attributable to the natural vegetation on salt marshes. When we look at salt marshes in the province, we know that the coastal landscape has been affected by human decisions going back hundreds of years, including diking and building structures, building towns, building harbors. All of these kinds of things affect what our coastline looks like now. And a lot of what we're dealing with when we think about restoring salt marshes is dealing with some of the decisions that were made in the past that may be affecting tidal flow in current day. So we'll talk about some of the implications of some of those things. One of the problems is something we call coastal squeeze. And essentially, I talked about how marshes will move inland as sea level rise. sea level rises. But that can be prevented by human structures like seawalls or roads or dikes or anything that impedes the ability of a system to track inland. So largely, when we talk about restoring salt marsh systems to where they used to be, it's dealing with whatever barriers we've put in place. And here's an example of one in southwestern Nova Scotia, Mavilette. And Mavilette Beach, basically the road is an issue for coastal squeeze, preventing, in part, preventing some of these systems from moving inland. However, we've shown in other parts, especially in the upper bay, that when you have the right conditions, reintroducing tidal flow can stimulate rapid recovery of wetland vegetation. The specific type of vegetation, whether it's more freshwater or more salt marsh vegetation, depends on essentially how far up the river you are, how much freshwater influence you have in your system. But it can be quite fast once you reestablish tidal flow. So this is the basic principle of restoring a salt marsh, at least in this region, is to focus on tidal barriers and removing those. The reason vegetation can recover so quickly is because there are plant sources all over the place. So one of the things we've discovered is ice rafts in the winter, especially in the upper bay. They actually will rip out huge chunks of living vegetation and move them somewhere else. And so these big ice rafts will end up on maybe a new mudflat in the spring. And if they stay there, they'll melt out, and all that sediment that's in there gets deposited and adds to the new system. And we've also discovered that there's live rhizomes present in these ice blocks. The other thing that's washing around in the ocean is dead plant material that may have seeds in it from the last growing season, essentially. And so this is also a potential source for recolonization. So the restoration projects that we've undertaken to date with this team, with CB Wetlands and environmental specialists, Transcoastal Adaptations, which is more of an umbrella group, and St. Mary's. A lot of these projects have been passive restoration projects, hardly passive. There's a massive amount of restructuring the physical environment to allow tidal flow to come back, but there hasn't been very much active planting yet, and I'll touch on that at the end. So we've got a few local projects, so local to southwestern Nova Scotia, depending on where you draw the map, or the boundary around the southwestern Nova Scotia bioregion, Gijuktoukwitch site, the Belcher Street site on what was formerly known as the Cornwallis River, is one I'm going to talk about, even if maybe it's slightly out of range here. But we've got a couple active restoration sites at Mavilette Beach, Abrams River as well, and I'll talk about those. Morris Island didn't go forward. We did some baseline stuff, so we've got data from down there, but it hasn't been restored yet. One of the other contexts that is allowing tidal marshes to be restored, especially around the upper Bay of Fundy, especially where there's a lot of dike lands, we call it managed realignment. So it's recognizing that sea levels rising, coastal effects like erosion and storm surge are increasing, and some of our infrastructure at the coastline is suffering and needs to be replaced or possibly abandoned. Things like dikes that are, require a lot of money to fix and maintain, that kind of thing. So managed realignment is chosen in cases where the community deems that it's actually better to release the dike, essentially rebuild a new dike farther back. And this whole area of land that was being affected by, overwash or things like that, now becomes a restored tidal marsh, which is great, which provides, carbon sequestration and more coastal protection than the skinny little foreshore marsh you see up there. And basically the dike gets rebuilt. Well, it gets rebuilt here. That's one of the first things you have to do, farther back. So it's in some cases we call it a managed retreat, but there's a bunch of different techniques involved in this. Kirsten Ellis is going to talk next about some of the living shoreline techniques that we use just for coastal protection. So I won't get into that, but I will talk about this site just briefly. This is the Gijuktoukwitch site, and it's a managed realignment site. So this area back here is the new area that's protected, but the old dike covered a huge area. I'll show you an aerial. It's a little bit easier to see. And so part of the restoration involved shortening the dike, pushing it back. So now there's less dike to maintain. It's been stabilized. The new dike provides better access for people to access the system, whether they're hunting waterfowl or just hiking or whatever. And yeah, so this is what it looks like. So again, this green is the new bit that's protected, and so this is still cropland. And what was lost, essentially, we don't consider it a loss, we consider it a gain, but there's some marginal cropland in these areas, I guess. And this is the old dike footprint you can see in here. Kirsten's going to talk more about this site because she's doing all these cool things as part of the living shorelines approach, and I'm not going to talk about it anymore. But in terms of salt marsh restoration, what we found only a year after this managed realignment was undertaken, so now tidal flow is happening again. We're behind where the dike used to be. We're seeing a massive accretion of sediment in over most of the site, more than a foot in some cases. So it's basically a whole bunch of mud has been dumped there. And so this marsh is already starting to store carbon that previously was floating around in the bay and could be decomposed or broken down, or things like that. Right. So this is work. It's also got a ton of vegetation on it, which I won't get into at this point, but it's happening. It's happening very quickly. How do we evaluate the success of a restoration project like this? There's a whole bunch of data that we collect in terms of long-term monitoring. Especially we do it before the project, we do it the first year after, and then hopefully at least up to 5 years after this is all started. So we're looking at things like soil and sediments, how much the marsh is actually changing, plant communities, animal communities, and of course hydrology. The main thing that we do in this case is we compare the restoration site to a reference site, which would be a natural salt marsh, hopefully in the same watershed or at least nearby, that has similar elevation conditions. And it allows us to kind of predict what we're going to find at the site that we're restoring. That's how it's supposed to work. So a lot of these sites, and the Southwestern Nova Scotia sites, are all in this early stage of transition where things are changing. Tidal flow is coming in. Terrestrial vegetation may be dying off because it's not salt tolerant. You may get lots of mud. You may get lots of bare patches where some of the old vegetation has died before new stuff has colonized. So that's important to recognize, that the transition stage isn't always pretty, depending on how fast the plants come back. And then we almost always see this establishment phase where the vegetation is starting to come back. And I'll talk about this in the context of our local sites in a sec. And then the older sites show some kind of equilibrium where things aren't changing as fast anymore, and you've got a nice salt marsh there. When I talk about the Mavilette Project, this is a classic case of basically the old road used to cross over this little crossing here, and it was a very narrow opening, preventing the site from flooding as it would have prior to the construction of that. And so, nothing simple about this, but essentially earthworks were done to expand this opening and make a much nicer bridge. And this ended up restoring the hydro period to the site. So now it's flooding like a normal salt marsh would. It's only a couple years in at this point, so it's a little early to tell, but we're already seeing essentially some shifts in vegetation in response to basically it being a more tidal system now. And so that's happening. We're seeing some changes, but we're also seeing some changes, a shift from high marsh to low marsh, which are two different vegetation types at the reference site as well. So we think in addition to these restoration activities, we're also seeing effects of sea level rise. The reference site or the natural site, we don't manipulate these, right? So any changes there are just, that's what the region is experiencing. Abrams is very similar, and so the reference site here is just right next door to it, essentially. But again, there was tidal restriction. There was a faulty abuteau that wasn't allowing this system to flood like it had historically, and so essentially, redoing these entrances, redoing the bridges and the road so that tidal flow is reestablished. And again, seeing a lot of increase in halophytic vegetation. These are the salt marsh plants. These are salt tolerant species that we expect to come back there. There's been some dieback as well, which sometimes happens at our site. And puzzlingly, we found this at the reference site as well. And so there's, basically these are areas that are becoming devegetated, and whether or not, how quickly those will become revegetated is unclear at this point. The fact that it's happening at the reference site likely indicates something going on with sea level rise, and we may need to do other things to account for that. And I'm going to end with talking about some of the research that's ongoing in our group. We're looking at, what's on the site before you start reintroducing tidal flow, what kind of vegetation is there, when you reintroduce tidal flow as factors that could influence the trajectory of restoration. We are looking at carbon sequestration, how the different vegetation types do this, the role of mycorrhizal colonization, and tricky stuff like gas flux. So there's a lot of partners involved with this, not just me. We're looking at the ability of plants locally to attenuate wave energy. So we have some student projects on that, and we know they do, and we know they do attenuate wave energy. We're just trying to quantify at this point. And a bunch of other stuff, including active planting, where we actually go in and put plants in the ground to help speed up the recovery. And I'm going to leave it at that now, and hopefully a little bit of time for questions and acknowledging all our funders. Thank you.
Thank you, Jeremy. And we do have time for some questions, about 3 minutes. So Steve, if you wanted to moderate that, please.
Certainly, there are no questions in the chat now, but I invite people to jump in with them because certainly it was an interesting talk. That's funny. I was at that
co-authors in their natural habitat.
What's that?
They're my co-authors in their natural habitat.
Yeah, I was actually at that Mavilette site the other day. It's an interesting spot.
Yeah, one of the things we're finding is I think Abrams is having some sedimentation for sure. There's definitely sediment there. We know that. We know there's not as much sediment as the Upper Bay, but it's still, compared to New England, for example, a lot of sediment. Mavilette, not as much sediment, and that might be an issue.
Yeah. It's funny. I have to say, one of my great regrets is when we moved here in 1988, my first drive across the Windsor Causeway, it was the beginning accumulation of unconsolidated mud. And I really wish I had taken annual pictures from a fixed spot.
Yeah, we've got a few aerials that Danica always shows those, and it's astounding. I mean, it's a very fast development of a massive ecosystem.
Oh, absolutely, yeah, and it's huge.
Yeah.
I have a question, Jeremy, around your clients. Do you tend to work for the province, like for kind of Provincial Department of Transportation Infrastructure, or have you been able to engage municipalities in some of the work?
It's more provincial agencies. So earlier, and still to this day, NSTIR, when they have to do a bridge modification or something like that, fixing infrastructure, there's often a habitat conservation piece. So that was motivating a lot of the earlier projects, and some to this day. But we're also working with Agriculture Nova Scotia, especially when it comes to dike realignment, because they rule the dikes, right? They're in charge of maintaining those dikes and working with the farmers, working with the communities to figure out what's going on in the system. So a lot of it is provincial.
Great, thank you very much. And if I could ask you to monitor the chat for a few minutes, there may be some questions that come into you
sure.
During the next presentation. Thank you so much. Fascinating work.